High mileage on a car does not happen by accident. It comes from simple engine design, durable transmissions, and parts that do not cost a fortune every time something wears out. The 7 vehicles in this lineup are known for crossing 300,000 kilometers with just basic maintenance and without turning ownership into a money drain. Starting at number 1, the Toyota Corolla earns this position because of something that rarely gets attention in flashy reviews: mechanical restraint. Instead of chasing complicated layouts or experimental drivetrains, most Corolla generations rely on a naturally aspirated 4-cylinder engine built around long-proven architecture. Multi-port fuel injection on many versions avoids the carbon buildup, risks associated with some direct injection systems. The engine block design prioritizes stable operating temperatures and even cooling flow, reducing the kind of thermal stress that shortens lifespan in higher-strung setups. When oil changes are done on schedule and the correct viscosity is used, internal wear stays predictable rather than accelerating unexpectedly. The transmission options also play a major role in longevity. Traditional torque converter automatics used in many global markets are engineered for smooth engagement instead of aggressive shift mapping. That reduces clutch shock and internal friction spikes over time. Manual versions, where available, are known for simple clutch replacement procedures and durable gear assemblies. Even later CVT variants, when serviced with proper fluid intervals, have shown consistent long-term performance compared to more complex dual-clutch systems found in some competitors. The key factor is not marketing hype, but reduced mechanical strain. Suspension design follows the same philosophy. MacPherson struts in the front and a torsion beam or multi-link rear setup, depending on generation, keep component count manageable. Fewer moving joints mean fewer long-term failure points. Bushings, control arms, and sway bar links are widely available at reasonable cost, which encourages owners to replace worn items early instead of delaying repairs. That matters because neglected suspension parts often cause secondary wear elsewhere. With this platform, maintenance tends to stay isolated rather than cascading into larger mechanical problems. Electrical architecture is another reason this model repeatedly crosses 300,000 kilometers. The wiring layout avoids overly complex module integration compared to many modern vehicles loaded with experimental tech. Core systems such as ignition, charging, and fuel delivery operate through established designs that technicians understand well. Diagnostic procedures are straightforward, and replacement sensors are affordable. That reduces downtime and keeps ownership realistic over long distances. Cooling system reliability is often overlooked in durability discussions, yet it directly affects engine life. Radiators, thermostats, and water pumps in this vehicle are designed around steady thermal regulation rather than extreme performance targets. When coolant is replaced at proper intervals, overheating events are uncommon. Avoiding repeated heat spikes preserves head gasket integrity and internal sealing surfaces, which are critical for engines expected to exceed 300,000 kilometers. Fuel efficiency also indirectly supports longevity. Lower stress during daily commuting means pistons, rings, and bearings are not constantly operating at high load. A balanced power-to-weight ratio prevents the drivetrain from working beyond its intended limits in routine traffic. This is not about speed or headline horsepower figures. It is about consistent operation within safe mechanical margins year after year. Parts accessibility across global markets strengthens its long-term outlook. Because millions of units have been produced, aftermarket and OEM components remain widely stocked. That keeps repair decisions practical instead of financially overwhelming. Owners are more likely to maintain a vehicle properly when service costs remain reasonable. That consistency is what allows many examples to accumulate high mileage without being abandoned halfway through their lifespan. Rust protection varies by region, Yet body structure durability has generally been solid when basic care is followed. Regular washing in areas with road salt and prompt treatment of small paint chips can preserve structural integrity well beyond typical ownership periods. The chassis does not rely on overly complex structural gimmicks, which simplifies inspection and repair if needed. Reaching 300,000 kilometers is rarely about one single feature. It is the result of predictable engineering, stable operating temperatures, manageable electronics, and accessible maintenance. This model combines those elements in a way that supports long-distance ownership rather than short-term excitement. That is why it holds the #1 position here. Number 2 is the Honda Civic, a model that has consistently proven capable of surpassing 300,000 kilometers in real-world use. The engine design favors mechanical simplicity over complexity, with naturally aspirated four-cylinder options that avoid high-strung components prone to early failure. Fuel delivery systems are straightforward, maintaining stable combustion while minimizing buildup and stress within the cylinders. Transmission systems, including traditional automatics and manuals, operate with predictable engagement patterns, reducing frictional wear over time and helping the drivetrain maintain smooth function even at high mileage. Suspension components, including struts, control arms, and bushings, are easily serviced and widely available, which keeps long-term maintenance practical and prevents minor wear from creating larger issues elsewhere in the chassis. Braking components, steering linkage, and wheel bearings are designed for durability, with parts that can be replaced without specialized tools, further supporting long-term usability. Electrical systems are intentionally simple compared with many modern compact cars, limiting module interdependence and reducing the likelihood of intermittent sensor alerts or electronic faults that require frequent diagnostics. Cooling and fuel systems are also designed for longevity, with radiator flow and fuel pump operation calibrated to maintain consistent performance under typical commuting and highway conditions. This combination of simplicity, accessibility, and stable mechanical operation allows the Civic to accumulate high mileage without frequent, expensive intervention. Long-term ownership is supported by widespread parts availability and clear service procedures that mechanics are familiar with, ensuring routine inspections, fluid replacements, and minor part swaps do not become burdensome. Owners can maintain consistent operation for decades, with the vehicle retaining its core performance characteristics even after crossing the 300,000 kilometer mark. That balance of service-friendly design and durable systems makes the Honda Civic a reliable choice for drivers seeking long-lasting, high-mileage transportation. Number 3 is the Mazda 3, a compact car known for combining solid engineering with long-term mechanical stability. Its naturally aspirated Skyactiv-G engines are built with high compression ratios, but balanced internal components that manage heat and stress effectively when maintained with proper oil intervals. The design avoids unnecessary complexity, keeping the intake, exhaust, and fuel systems direct and serviceable. This reduces the risk of cascading failures that often appear in heavily over-engineered platforms after extended mileage. Transmission options, including conventional automatics and manuals, are tuned for steady engagement rather than aggressive shift behavior. That calibration helps limit excess internal wear over time. Drivetrain components such as CV joints, axles, and mounts are constructed to handle daily commuting loads without premature deterioration, provided routine inspections are not ignored. Cooling systems are engineered to maintain stable operating temperatures even in warmer climates, which protects internal engine components from long-term thermal stress. The chassis structure is rigid, helping suspension parts operate within proper alignment specifications instead of compensating for flex. Struts, bushings, and control arms are widely available and reasonably priced, allowing worn components to be replaced before they affect tire wear or steering stability. Brake systems are straightforward, avoiding complicated electronic dependencies that can complicate routine service. Electrical architecture is relatively organized, with fewer overlapping control modules than many competitors in the same price range, reducing diagnostic complexity as mileage climbs. Interior electronics and infotainment hardware are integrated without excessive reliance on fragile touch-sensitive panels, which supports durability during long ownership cycles. Fuel economy remains efficient even at higher mileage, helping offset long-term operating costs. When maintained consistently with fluid changes, filter replacements, and periodic inspection of wear items, the Mazda 3 has demonstrated the ability to exceed 300,000 kilometers without turning into a constant repair burden. That combination of structural strength, manageable maintenance demands, and balanced mechanical design secures its place in this lineup of high-mileage capable affordable cars. Number 4 is the Toyota Camry, a midsize sedan known for steady long-distance durability. Most versions use a naturally aspirated four-cylinder engine that runs under moderate stress during daily driving, which helps internal parts wear slowly over time. The engine layout leaves room for cooling airflow and routine servicing, making oil changes, belt replacements, and filter swaps straightforward instead of complicated. Transmission design focuses on smooth gear transitions rather than aggressive shift timing. That reduces internal shock and helps preserve clutch packs and seals across high mileage. When fluid is replaced at proper intervals, gear operation tends to remain consistent even after years of commuting and highway use. The Camry's suspension setup is stable and built for regular road conditions rather than performance tuning. Control arms, struts, and bushings are widely stocked in parts stores, which keeps upkeep manageable. Brake components are uncomplicated, allowing timely replacement without specialized equipment. Electrical systems are organized in a way that limits unnecessary module overlap, lowering the risk of repeated warning indicators as the vehicle ages. Fuel efficiency also supports longevity because the engine does not operate at high strain during normal traffic speeds. With steady maintenance and proper inspection of wear items, many Camry units continue operating past 300,000 kilometers without becoming a constant repair expense. Its balanced design, accessible parts network, and consistent mechanical behavior make it a practical option for drivers focused on long-term use rather than short-term features. Number 5 is the Honda Fit, a small hatchback designed for practical, long-lasting use. Its engine is compact and uncomplicated, focusing on steady performance rather than high output, which reduces wear on pistons, valves, and bearings over time. The fuel and ignition systems are easy to reach and service, allowing routine maintenance to stay simple and cost-effective. Transmission options, both manual and automatic, are engineered for smooth, predictable operation. Gear changes place minimal stress on internal components, which helps the drivetrain remain reliable even after extensive city or highway driving. Suspension components are straightforward and compact, with widely available replacement parts that make servicing routine rather than difficult or expensive. Brakes, steering linkages, and wheel assemblies are similarly simple, reducing potential points of failure. Electrical and auxiliary systems are designed with clarity, avoiding unnecessary overlapping modules that can cause repeated sensor or control issues. Cooling, exhaust, and lubrication systems follow proven layouts, helping to maintain stable operation for hundreds of thousands of kilometers. The vehicle's lightweight structure also reduces strain on mechanical components, keeping wear predictable and consistent. With careful maintenance, periodic fluid changes, and timely replacement of worn parts, the Honda Fit has proven capable of crossing 300,000 kilometers without constant repair needs. Its reliability comes from simple design, accessible parts, and balanced mechanical systems, making it one of the most high-mileage small cars available. Number 6 is the Hyundai Elantra, a compact sedan that performs reliably in everyday driving without unnecessary complications. Its systems are organized for accessibility, so routine checks such as fluid levels, tire wear, and filter changes are straightforward. The layout avoids overcrowding components, making inspections faster and reducing the chance of overlooked maintenance. Gear operation is smooth under normal conditions, with careful calibration preventing sudden strain on moving parts. Steering and suspension work together to absorb road irregularities without creating uneven stress on critical joints. Brakes remain simple to maintain, and replacement parts are widely available, which keeps servicing efficient and predictable. Electrical circuits are clearly arranged, minimizing confusion when diagnostics are required. Essential sensors and modules are easy to reach and replace, preventing small electrical issues from becoming time-consuming problems. Cooling and fuel delivery are steady and controlled, supporting stable performance without extreme fluctuations. Through consistent servicing, timely replacement of worn parts, and monitoring basic wear items, many Elantra vehicles can surpass 300,000 kilometers without encountering frequent mechanical problems. The design focuses on simplicity, ease of care, and reliable operation across a variety of driving conditions. Number 7 is the Mazda CX-5, a small SUV built to last with straightforward design. Its engine and transmission work steadily without complex systems that can fail early. Suspension and brakes are easy to check and replace, and parts are widely available. Electrical systems are simple and organized, so issues are easier to fix. With regular maintenance and timely attention to worn parts, the CX-5 can reach very high mileage while keeping performance consistent over time.